Composition. Oh, well, that was anticlimactic. Well, 2 is composition. Are you guys writing me a quick summary of any fill in the blanks like you're supposed to? Good, good, good. Number 10. Did you try to go too far? Did you do anything illegal, or did you leave it the way it had to stay? Did you go too far? Was there any way to combine like terms? No. No. Make it look a little prettier, I suppose. Put him over 1. Multiply by the reciprocal, but you're still stuck. Just so that you guys know yourselves and your your tendencies, I guess, your mathematical tendencies. Watch out. If you started crossing off things like x squareds, or if you started like saying this is x minus 2, you're doing things like killing kittens, or you're killing puppies, if you're doing any of that sort of stuff. If you're somehow magically, I don't even know what else, but if you're crossing off top and bottom, that's illegal. You have to have factors being the same. And at the very, very bottom, why was there a domain problem? What was going on in letter D? Okay, good. Division. So first of all, division, denominators can't be good. But what else was there besides division? There were 2 things. Okay, so not only could x not be 0, which is a part of, or didn't even talk about that one. And here's why. Give me a second. X can't be 0, which is true. But also x squared minus 4. Okay, so for square roots, radicand must be larger than or equal to, right? Greater than or equal to 0, aka can't be negative, right? So then greater than or equal to 0. Some of you guys might have forgotten how to solve when you're square rooting with not absolute value, with greater thans or less thans. Let me show this real quick. I'm not going to take a lot of time on it, but this is something in Algebra 1 that kind of gets lost because there's so much going on in Algebra 1. I mean, you guys are learning polynomials for the first time. You're learning foiling and distributing and exponent powers for the first time. You're learning factoring for the first time, the quadratic formula. There's a lot in Algebra 1. So this kind of gets lost. Question for you. What's the square root of x squared? Why? Here's the weird thing. This is always a positive number, right? So it's actually not plus or minus. Because if I was to plug in a negative number and square it and square root it, wouldn't it be a positive? Because it loses its sign, right? When you square it, PEMDAS would say square and then square root. So a negative squared, it loses its sign. It loses its negative identity. This is technically absolute value of x. If you put that in your calculator, any number would always be a positive when it comes out. But this is the reason why we always use plus and minuses. So Joe wasn't too far off. He said plus or minus. That's a thing. But how is it a thing? Do you remember in Algebra 1, whenever you had something like the absolute value of x plus 1 is equal, not even that. Let's make it easier than that. I did that with an honors calc? I don't know. What if I just said this? How do we solve an equation with an absolute value? Do you remember? 2 equations. Good, 2 equations. One equation says, hey, x could be a positive 4. The other equation says, hey, x can be a negative 4. Right? Put in a positive, get out a positive. Put in a negative, get out a positive. There are 2 different ways that could happen. So how does that apply to this at all? I'm looking at this guy. We're supposed to solve that guy. And in solving that guy, we move the 4 to the other side and we say, sweet. Let's square root. Now, technically, some of you might be able to apply my whole always factor, always factor, always factor, and maybe you could figure this out a little bit easier, that you have to look at plus and minus 2. But I think the inequalities would still get really confusing even if you did factor. You'd have to remember how to solve inequality expressions from like Algebra 1, and that was making number lines and seeing where there's overlap and Okay, let's just assume that we can plus or minus, well, wait, plus or minus. Technically what we would do right here is we would take this guy and we'd square root the x squared and we'd square root the 4. There's no magical plus or minus. Some of you guys just think it's magical and pops out of nowhere. And if you don't remember it, then your magic's just, I don't know, need a new wand or something. But what you're really doing is the square root of x squared is an absolute value of x. And here's where it gets a little tricky. Well, how do I do absolute value of x? Two equations, plus or minus, but here's where it gets a little tricky with inequalities. The positive one, in essence what you're doing is you're remembering, ooh, we did this the other day, that sometimes absolute value stays the same and sometimes it's opposite. Didn't we talk about piecewise functions? Okay, so absolute value keeps it the same when the number is positive, right? Positive number, the absolute value does nothing. It stays the same. But if it's a negative number, if it's negative 2, well, that negative 2 gets multiplied by a negative times a negative is a positive. So what, in essence, we're doing is we're taking this little definition of a piecewise function. We're saying, okay, so if the absolute value of x is greater than or equal to 2, then that means that sometimes our two equations, x is greater than or equal to 2, or negative x is greater than or equal to 2. Technically, every time you do a plus and minus, what you're doing is using the definition and saying, hey, the other side can be plus or minus, but you're skipping the step of the original could be plus or minus. So this one stays the same, the inequality stays the same, no big deal. Why am I making a big deal about this? What happens to this guy when you move him over here? Because when you multiply or divide by a negative, what happens to the inequality? So if any of you guys were wondering, well, why is one greater than or equal to where the other one is less than or equal to, it's all based on the definition of an absolute value of x. How it can sometimes be positive, sometimes be negative, which ends up to what Joe said, plus or minus, but in getting the plus or minus 2, this inequality gets flipped. But couldn't you also, I mean, some of you are like, oh, I have to think that every time? I can't. Well, pause. Can't you always double check in the actual expression itself as to whether or not you're right? For instance, greater than or equal to 2. If you figure out plus or minus 2, check a 3. Does 3 squared minus 4 work under a square root? Yeah. Okay, well, if you thought it was greater than or equal to negative 2, try a negative 1. Would that work? No, so it can't go higher than negative 2. It has to go lower. So you could always plug in, oh, here, good. You can't always plug in numbers to make sure you're right. And if you plugged in negative 3, oh, that works, because 9 minus 4 is a positive. Dun, 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 dun. Anyway, this is the reason why there is this little trick called a plus or minus. There's no trick to it. Just some of you guys have learned a shortcut that, I don't know, gets you confused. Sorry to harp out on that, or to harp on it. But a lot of you just don't know what to do with a squared and a square root and when to use plus or minus and when not to. Oh, hey, look, absolute value. Anyway, okay, the rest of homework grading should go pretty fast. As long, ooh. Did you guys remember what's going on? Read this to me. F plus G. No! Ah! Ah! Come on. Didn't we talk about it on Friday? It's not multiply. It's of. But do you see how your brain gets confused? Come on. We've seen parentheses since Algebra 1. It always means times. Not now. Say it again. It's F plus G. Which means f of t minus 2 plus g of t minus 2. Okay, grade it if you haven't yet. I'm making a point, though. You guys just were like, why is she spending time on this? Your brains don't always do what they're supposed to do. Don't always think the way they're supposed to think. Sometimes what's wrong seems right, and what's right seems wrong. Oh, so many life lessons in there. Did you guys foil? Didn't kill any puppies, right? If you did, you're marking it, you're starring it, you're saying watch out. You got to foil that, and then combine my terms. Okay, number 32. He's a bit of a party. Did you put the G inside the F properly? Did you put the F inside the G properly? And they didn't draw little boxes, but they could have. While you guys are grading, let me get my little boxes just for a few of you for whom that visual does help. Looking at the F, there's his argument. The G needs to go inside. Rewrite this. It's so much easier, I think, on your brains than that one. So then the 5 minus x, who is g, gets plugged in to the box spot. There's no magic to it. G's function got plugged where he needed to get plugged. 3 times who? 3 times g plus 5. And similarly, this one, f gets plugged in. 5 minus who? F's function gets plugged in that spot. Don't kill a puppy. Ah, no seal. Sorry, distribution. 5's canceled. There we go. Then letter C, it was its own inverse, which is kind of weird. Number 42, 44, 52. There's a lot on the screen right now. I don't know about you, but 42 got hard because it started talking about domain. Did anybody get that? Got a little bit hard because of domain. If it helps, we could still think about the boxes. I know, you're grading. Hold on. So you can see it all. Just plug in the F. The G's function got plugged in to F's input spot. Didn't kill a puppy, had to FOIL it out, combine like terms, got it. Can't cross anything off or reduce anything. Denominator can't be 0, they factored it. If F goes into G, it's going to go into G's spot. What plus 1? F plus 1. Whoa, 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 whoa. Sometimes they do this in the answer key. What's this huge jump? What just happened to go from here to here? Okay, so Joe's saying convert. What he means, which it is converting, that's true. But what's the big picture? You're multiplying 1 by x squared minus 1 over x squared minus 1. What's the same? It's 1. But what are you getting? What's this called, this whole process? Common denominators, good. So then you can go ahead and combine by adding 3 plus x squared minus 1, which ends up... Okay, so there was definitely some simplifying to do in 42. For sure, for sure. They were combining like terms, but they had to get common denominators first, etc., etc., etc. Oh, and 52 is the last one. Does anybody have another option for decomposing functions? That wasn't the only right answer. Anybody have one they think is right? That's different? Breaking it down, breaking it apart. You guys all did the same one? Do you have like another way of doing it, Joe? Another G, another F? This one was kind of hard, I think, to do it any other way. Okay. This one's kind of hard because it's kind of like what's outside 4 over something squared. What's inside 5x plus 2. So maybe that one was pretty easy. Every now and then someone comes up with something different. What else it could be? So no one had anything different? Are you thinking? Oh, like this one's F and that one's G. Okay, that would be okay if we were allowed to write it like this. Does that make sense? You were like, you weren't decomposing. You were, well, you kind of were. You were breaking down into a division problem, but we had to break it down into a composition. Does that make sense? So that's good breaking down, but for the wrong problem. They were asking to break it down not as a division. So good asking. But instead breaking down so that you're putting one inside the other to get there. Joe. You could do that. 4x, it is a little bit weird, and it's more complicated too. 4 times who? 4 times 1 over 5x plus 2 squared. You could do that. Like 4 times what? 4 times this guy. That would end up there. You could do something like 4 over x plus 2 squared. Can anybody figure out how that could be this function? 5x. So the 5x could have gotten plugged into that spot, and that would work. If I can think think of any other ones. Do you guys notice the difference, though, between these, like, weird ones and the ones they came up with? Is it something way more complicated? They broke it up in the simplest way possible. 4 over something squared, whose is something 5x plus 2. But those work. They technically work. Does that give you some more examples, Lauren? Does that give you a couple more to look at? Okay. All right, I think that's the end, kiddos. So I have the homework open right here. Anything that you want to ask on evens or odds? Yeah. 32A. Anything before 32? Can we skip down there? Yeah. 27. Okay, let's go 27 first and then 32A. So 27 is asking in the directions to graph all sorts of people. Point up my graphing calculator. Use a graph to graph f and g and f plus g. Which function contributes? You guys know what contributes means, right? Like adding to. Most to the magnitude of the sum. Oh, it's not going to let me do it for a second. Hold on. Yeah. Usually. It's very rare that a section is so easy. What was the one that was so easy? It was only one day. Like 1.1? 1.1 and then also 1.6. Yeah. The parent function one I think was easy. But it's pretty normal, Jordan, to have 2 days. Which is good and bad all at the same time. Because that means that the homeworks aren't super short. Because I kind of planned for them to be over a couple of days. But that you can kind of choose, have a little bit of grace as to when you end up doing it. Okay, so here's the dealio. Do you guys know what 3x looks like in general? You should. What's 3x look like in general? A line. Okay. What does, let me get rid of this guy. What does negative x cubed over 10? You guys remember where that cool fraction thing is? Alpha y equals. Makes a nice pretty fraction. Negative x cubed all over 10. We know what cubic looks like, right? Oh, this one, right? There we go. Careful, up. It needs to go up. There you go. Whoa. Jordan's doing some fun stuff back there. Anyway, so it's this guy. Okay? But negative cubic, what's going to happen? Vertical. It's going down. The over 10, I don't know. He like squishes. Anyway, so long story short, we know what that guy looks like with his little curvature. There we go. And we know that guy's a line. What we're trying to look at is as we look at the window 0 to 2, does the graph, when I zoom in, does the graph look more like a line or more like a cubic? That's what we're asking ourselves. Who's contributing more to what's going on? Let's change the window. Hold on, Joe. 0 to 2. I'm just zooming in on exactly what they told me to look at, just 0 to 2. So looking at 0 to 2. Dun, 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 dun. It sure looks like this guy, doesn't it? Oh, wait, f plus g. Is that what you were saying? My bad. How can I do f plus g in my calculator? I have to write the whole thing? Precalc graphing calculator handbook. What was the shortcut? How can we put f plus g in there? Who is f? How do we get y1s and y2s? Do you remember? Well, because I'm supposed to put f plus g in my calculator, and I'm like, well, we could type it all in. But how do we get the y1 plus y2 and not have to type it all in again? Not stat, not second math. This one, chapter 1, I think you can. Not second. Either vars, variables, or alpha to get to a shortcut. Which one do you guys want to do? Everyone's calculator? Okay, vars, variables. What kind of vars? I need some y's. What mode am I in? You could go back and look, but I'm in function mode. Oh, there they are. y1 plus. Now, some of you are like, that took forever. Yeah, there's a shortcut. Anybody whose calculator doesn't have a yellow button right here. Alpha, trace. There's alpha in all these hidden menus. You could just go steal them from there. Okay, sorry. So, we have our line. We have our cubic. And then we have our other guy. What does the other guy, the f plus g, seem to almost be perfectly mimicking? The line. Yeah, the y1. So therefore, Tyler, in answer to your question, the first one, for, what is it, 0 less than or equal to x less than or equal to 2. It sure looks like f of x equals 3x. He's the winner on that guy. But then they go on and say, whoa, 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 what's going on if x is greater than 6? So if you're zoomed in, man, this sum looks a lot like a line. So for very, very, very small values of x, this negative is barely taking away from that positive, which might make sense. But then all of a sudden it says x greater than 6. So if I was to go, I can even just zoom out if you want. Let's just do zoom standard. What happens to that little sum? There's a line. There's the cubic function. 1, 2, 3, 4, 5, 6. I'm looking past here. What starts happening? Who's he following now? The line? No. Why? If you plug in a 6 to this guy, who's going to be stronger? The negative pulling them down or the line trying to push them up? The negative pulling it down. Ooh, this could totally go in with chapel and like which voice are you listening to, whichever one you give the more power to. Seriously though, I had a youth pastor who would always say growing up, if one dog, like he basically, like a dog fight, he grew up in Wisconsin somewhere, I don't know, there was weird stuff going on up there, but dog fights, and he was like, which dog is going to win between like these two dogs if they're both yours, and he made one like, I think he did good choices than bad choices, but he's like, which one's going to win, like the flesh or the spirit, like which one's going to win? And he said, the one that you feed. If you starve one, it's going to lose, and the other one's going to win, whatever the size is. And not that you should go starving. I told you, he grew up in Wisconsin. I don't know. Don't ask. Don't ask. But it's the same idea. Which one is stronger? Well, in this one, we're talking about magnitudes. What we're asking is which one's stronger. The line is really, really strong for a little bit. But in the long run, who's going to end up taking over? The cubic function. Anyway, life lesson that to whatever extent you want. There's good stuff in there, but let's come back. We also had number, what was the other one? 32a. Jason, was that yours? 32a? 32a was an f of a g. What's the notation? What's the notation? F of. All right. F of g of x. So then who gets plugged into what? The g gets plugged into f's x, which would end up being, oh, sorry, that's not the question you were asking about. F's x. So therefore, g gets plugged into, you see it? Oh, so easy, right? That would totally mess you up. Yeah. Good. And that's part of the reason for me saying write the problem, because hopefully you write the right problem down. All right, any other questions? We did 32a, we did 27. Going once, going twice? Sold. Okay. And then Joey recorded the other stuff, so if you need anything else from earlier. All right, we're in our notes. You guys were taking this at the beginning of class, wherever notes just went. They're here somewhere. Let's get rid of him. Let's get rid of him. Let's get rid of him. Inverse functions. Okay, even though it's really, really sad and a little bit, I don't know what word you would use. I'll just use sad. Even though it was a little bit sad that you guys, the louder ones of you, made a mistake in class today, it's actually a really good illustration for what we're about to talk about. What am I talking about? Where was the one that I like screamed and went behind the board and like banged a little bit? I didn't scream, but of instead of multiply. And what was that problem? Do you remember it? I think it was F plus. Was it plus? Something nasty, right? Okay. And what did, and it's not at all to the discredit the person who said it. Actually, thank you, because you're an illustration right now. What was the word that I heard first when I asked you guys to read this? F plus G, and what did I hear? I heard times. But it was wrong, because it's supposed to be of. Okay, so this right here is of. And this was our struggle, at least I think it was one of the biggest struggles from last section, was figuring out the whole, what does the notation even mean before you even try to review function notation and plugging in and simplifying and what to combine and what not to combine, etc. Guess what one of the biggest struggles is going to be here? Jordan, go ahead. Yes. Yes. It's all about what's there. If you have something like x minus 2 and x plus 1, in context, two polynomials written next to each other will always be multiplied. Function notation. F's, G's, H's, J's, they're talking about, they need more. But if you have two polynomials, yes, 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 always multiply, always times. If you have names of functions, then it's going to be of. It's cool? Okay. Basically. Ready? I'm going to write something, and then we're going to go back and talk about why this isn't what some of you might think it is. So, I want you guys to go ahead and write a quick note. It can be off to the side. I know some of you guys have blank space. Go off to the side. That's fine. Doesn't need to be underneath. Quick note, off to the side of all this stuff. Okay? To raise functions 2 powers. Why on earth am I talking about powers? Isn't a power a raised number right after something, right? Squaring it, cubing it. I'm just going to put a comma because I already have a colon. To raise functions 2 powers, you would have to take the entire function and put a power on the outside. So if you wanted to square a function, if you wanted to cube a function, if you wanted to do the reciprocal of a function, you would have to put that on the outside. Notation with functions would force you, if you ever wanted to raise an entire function to a power, would force you to put it on the outside. Force you on the outside. So what's going on here? He's on the inside. And since he's on the inside, what word is going to be important instead? It's not. So it's not f to the power of 1. That's what it's not. To do that, you would have to write it like this. Instead, it's f inverse of. Why is it confusing? Because it's a -1. I know, but it doesn't. -1 power. Jordan. Yes. Because in your graphing calculators, doesn't it have above the cosine, doesn't it have cosine -1x? Is it the same thing as secant? Who's secant? 1 over cosine. Wait, why am I even talking about overs? I don't understand. Okay, pause. Real fast. Remember way back when? And you had to rewrite this with positive exponents. This was totally Algebra 1. What did the negative exponents mean or signify or show? Technically, every time you saw a negative, it really meant a 1 over. That was fine. That was fine. This is not. This one needed to go under. And wherever there was a reciprocal, it switched places. So the x to the -1 actually ends up coming down. The y to the -4 actually ends up going up. Whenever you saw negative exponents of variables or even numbers, it meant take the reciprocal. But is that true here? No. Because it's not f to the, it's f inverse. So from here on out, whenever we see this, what are we going to, or how are we going to read? Of x. There you go. Does that make sense? Now, inverse is what on earth are, well, what are those? Now, this whole page, it's going to help you start homework tonight. It's going to help you start homework tonight that's due on Wednesday. PS corrections, finish up for tomorrow. Because this page not only says how we can check that two functions are inverses of each other, take a second function, plug it into the first, everything gets undone but the x, or take the first function and plug it into the second, everything gets undone by. You can actually say that a function and its inverse, they're the undoing of each other. Ooh, life lessons in there too. But when you have an original function and its inverse, everything gets undone. The additions, the subtractions, the multiplications, the divisions, the powers, the radicals, everything gets undone, only an x is left. But also down here, you guys also wrote down the quick reminder of, wait, if you ever had to find your own inverse, what would you do? Let's say they gave you a function, something basic, I don't know, like 3x minus 1. And you're supposed to find the inverse? Wait a minute, I can't switch the x and y, I don't even have a y. Who is that? So you would go ahead and rewrite this guy to be like, oh, that's the original. Sorry, minus 1. And then where would you go? Inverse. Switch the x and the y. Solve for y. Pause, pause. When you get y equal to x plus 1 over 3, one quick note. Don't name him y. That's the original guy. Name him f. Inverse of x. Get out of here. Bye. Whew. That was a little rough. We'll practice more tomorrow. Start a little bit on 1-9 tonight.
I just want to keep it.
For these.